this from human preference is explained, and the next one is a reinforcement learning from human feedback on its benefits and challenges. Then I explain the goal and the motivation of the proposed method, DPO, and the DPO's loss function and its operating is explained, and then finally the experimentation is okay. So the improving large language models from human preference is a very crucial point. So large unsupervised language models, so-called LLMs, are pre-trained on extensive dataset, but they have remarkable capabilities according to various references. However, these models are trained on data created by humans with many various objectives, priorities, and skills. For example, so blog posts and Twitter, or so GitHub source code, or GitHub README documents, and so on. Very various, so very diverse resources. So some of these goals and skills may not be appropriate for emulation, nor be specific tasks or human preferences. And for instance, we want our AI coding assistant to understand and correct common programming errors, but we also want it to prioritize high quality coding abilities from its training data. And also, we may desire our language model to be aware of common misconceptions, but not endorse them. The selection of desired responses and behavior from the models' vast knowledge is essential for creating safe and high performance and controllable AI systems. So we have a goal to produce responses with high rewards while staying close to the original pre-trained LLMs. So the reinforcement running from human feedback, RLHF, is arising. So RLHF methods involve fitting a reward function model using a dataset from human preferences. So human preference datasets are typically the data formats like triplets. The first one is prompt or instruction. The second one is generated text and labeled as preferred. And the third elements are generation, but not preferred than the winner generation text. So, and the optimizing a language model policy using reinforcement learning and the RLHF achieves impressive conversational and coding abilities like Instructor GPT or the another Llama successors and so on to many. So, okay, so RLHF, the overviews are as follows. There are three steps. The first one is supervised fine-tuning. This is just a causal language modeling of the cross entropy loss. This is just imitating the winner's tokens, winner's sequence. The next step is reward model training. So the step 2 has a training data set of the pairwise preference data. So which generation should be chosen? And then, okay, so we have the two models, two neural networks, and then finally, we go to the reinforcement of learning steps, the steps 3. So, and the benefits and challenges of this framework is as follows. So, reinforcement learning from human feedback method accomplished impressive conversational and coding capabilities. In particular, so instruction following and so coding accuracy improvement. However, the pipeline is more complex than the usual supervised learning. It involves training multiple language models and iteratively sampling from the language model policy during training. This complexity results in very heavy computational cost because for each mini batch updating, we have to run this sampling set model.eval and call model.generate function of the Hugging Face. And generating takes quadratic time complexity. It's very heavy, in particular for the long context than thousand lengths. Okay, so the goal and motivation of the proposed method, DPO. So this paper's goal is to develop a simplified approach for policy optimization using preference directory. And motivation is to address challenges of applying reinforcement learning to large-scale problems like fine-tuning language models with more efficient manner. And the practical advantage is eliminating sampling generation for each policy update. So each mini batch is just taken from the data loader. Okay, so, but it's not a trivial one. So a key insight is 2 points for me. So the first one is to utilize an analytical mapping from reward function to optimal policies. So, and next point is to transform our loss function over reward functions of the reinforcement learning framework into a loss function over policies of the supervised learning framework. So, okay, so the okay, sorry, is there a question?
Yeah.
Yeah.
What do you mean by the first key insight, that mapping from reward functions to optimal policies? What do you mean by that?
Yes, I will explain it. Yeah, later. Yeah.
Okay.
Okay. Sorry. Okay. So this explanation is not so clear. So okay. So more formal or more mathematical ways as follows. So the also convert the reinforcement learning objective and then transform the reinforcement learning objective function into the DPO objective functions. So the reinforcement learning frameworks of this loss functions are different among these step 1, 2, 3. The first step is just a cross entropy, and the second step is to train reward models for generated pairs. So like the log-like referred between the two reward barriers. Uh, this formula, and the step 3 is to maximizing reward function. So with KL divergence regularized between the initial distribution. And okay, so the key insight is transform a loss function in the reinforcement learning framework into a loss function over language model policies in a supervised framework. So how can we achieve this derivation of the DPO objectives? So okay, so uh, I'll explain the outline of the derivation, outline of the calculation. So so the first, our reinforcement learning objective is this, and so the optimal solution to the KL regularized reward maximization objective takes the form something like, and but z of x is a partition function, so that the total sum of probability should be 1.0. So it's a bit it's a bit okay. So it's a bit complicated, but basically straightforward. So okay, so the sorry. Okay, so uh, this formula. Okay, so this equation can transform the reward objective into the or into the form which is not containing the reward formula. I mean, sorry. The the first objective is reinforcement learning reward regularized by KL divergence, and then we can calculate it this form, the equation number 12, and then the equation number 12 is transformed into the KL divergence between the language model policy and the optimal language policy. So finally the non-negativity of the KL divergence require the optimal solutions should be the conclusion that the language models and the optimal policy to maximize the reward should be the equivalent probability distribution. So okay, so we have the this form. We have this form. Okay, so but we have still the problem because it's difficult to estimate the partition function z of x. So we take log of both size and rearrange it. And then we obtain this formula. And the finally the so okay so the finally the reward model is about the difference between two function r star of x and y minus r star of x and y2. So the term on z is cancelled out via the following subtraction. So, and finally we get a reward model by rewriting the sigma's sigmoid function, and then we have the reward model like this. And okay, so we record that we have the probability of human preference data set in terms of the optimal policy rather than the reward model. This means this means so data set is given as a prompt text and winner generation text and loser generation text. Then so human preference data contains the optimal human preference generation text. So we can formulate a maximum likelihood objective for a parameterized policy like this loss function. So this contains the both y sub winner and y sub loser. So this is difference between the winner and loser. But the entire form is just a log likelihood and fully supervised loss function. So, okay, so PyTorch implementation is very straightforward for me. Yeah, so 4 kinds of log probabilities of the data set is given at here. Pi y w log probabilities and pi y l loser log probability is given, and a reference model. And this is a pre-trained initial weight. A log probabilities is given for the winner, and then same reference model log probability is given for the loser. Then we calculated this log probabilities ratio and this log probabilities ratio. Then we get a pi log ratio and a reference log ratio, and then we have this log sigmoid function, this part log sigma. So the actual implementation is just 5 lines. Okay. So what does the DPO updating gradient do? So this is very interesting for me for now. Mechanistic understanding of direct preference optimization. So it is convenient to analyze the gradient of the log function, loss function. So the gradient is the multiplication of the 2 factors. One is a term to enhance to estimate reward correctly, and the other one is enhancing to choose was more preferred by humans. The second red term is a naive, straightforward, supervised imitation. And policy LMs also predict prioritizing weights for reward function without using another reward neural networks. So I think that this green term is an alternative of the step two, but but step two means I mean so step two is achieved with no separated reward neural network. This neural network, but only just a single language models has loss function with the reward prioritizing weights. So this loss function has two roles. Yeah. Okay, so to sum up, the contrast with prior reinforcement learning methods, unlike RL methods, this approach skips the reward modeling step and optimizes the language model using preference data. So the benefit is to avoid the explicit reward modeling step while still optimizing on the established model of the human preferences, like the Bradley-Terry model. So the essence is, for me, is as far as the single language model serves as a representation for both the policy, which choose tokens in a generated sequence, and the reward model to scoring or evaluation the generated sentence in a RL framework. So the single language model is single rows functions operating, but the single rows function has actually two rows, a reward calculation and so a word choice imitation. Okay, so is there a question? Here.
Yeah, I have a question. So for this to work, the underlying base language model has to be already very good, right? Like you can't start using BERT and apply the same thing. The underlying language model already should itself be very good.
Mm-hmm. Okay, so in this, sorry, I question about the baseline model. So initial pre-trained model.
Yeah, yeah. With on the one you're trying to give the human preference for that model. That baseline model itself has to be good enough already, like GPT or BART of some big size enough, or that in a big enough size.
Yes. Okay, so I think that the pre-training is not enough. So okay, so the pre-training data has some so statistically frequent misunderstanding or misconception. So for example, so a trustful question answering by the OpenAI. Okay, so I think that this adversarial data set means so pre-training language model has something so highly likely but factually wrong text is generated as the initial weights. Yeah. So and okay, and so for example, the software coding in the GitHub has a lot of bugs. So the version 0.1 has a lot of bugs, and then version 0.2, some bug wrong code is fixed. But so GitHub diff commits has all wrong and correct source code are contained. So yeah. So I think that so maximum low likelihood pre-training by causal masking and cross entropy pre-training cannot understand the such so quality improvement. Yeah. So I think that the pre-training actually run as this red part, just imitating the given sequence. So, but the which okay, so I think that the important part of this DPO loss function is the first term prioritizing weights. Yeah. So this prioritizing is given by the human preference. So by this data set is so triplet. So okay, so it may not be the answer for you. Yeah. So sorry. Actually, I'm not completely sure for the answer.
It's okay. Thanks.
Yeah. Okay. Thank you. Yes. So, all right. Okay. So let's go to the experiments. The three kind of tasks are examined. So the first one is IMDb. So this generating positive movie comments, and the second one is summarization. TLDR, sorry, TLDR prompt. And the third one is Anthropic dialogue assistant, generating both harmless and helpful information provider. Okay, so the evaluation methods are three kinds. The first one is rewards for each care divergence between learned probability and any probability. The second third human judgments and GPT-4 API judgments. Okay, so the first result is reward plot of the IMDb sentiment generation. So this experiment is very impressive. So the x-axis is about the KL divergence, how far the rand policy from the initial pre-trained parameter probability. And the y-axis is a reward value. So the other method like uh, reinforcement learning PPO is overwhelmingly inferior than the proposed method DPO. DPO outperforms for every x-axis value. And the second experimentation is anthropic, harmless, and helpful dialogue human evaluation. So yes, DPO outperforms for any method. And the difference between temperature 0.7 and 1.0 is small. Okay, so so the next task is TLDR summarization, human evaluation. So the orange line is DPO and pink line is PPO. So DPO outperforms for any sampling temperature. And so the final experiment is about GPT-4 automatic judgment. So I think that this experiment is a bit complicated. And so let's explain it. So the author proposed two GPO prompts, GPT-4S prompt and a C prompt. The S prompt focuses on better summarizing important information. I think that this is a recall-oriented evaluation. And the GPT-4C prompt also evaluated conciseness because of GPT-4's biased preference for the longer summaries. So I think that this evaluate redundancy and recall trade-off. So so the evaluation framework is like this picture. For each method, SFT, PPO, and DPO, the text pair A and B are generated, and then human evaluation and GPT-4 evaluations are generated, and then do they agree with their A-B choice? And agreement is assessed. So, so let's look GPT-4 concrete prompt. So the S prompt means recall-oriented evaluation. So very simple instruction, which of the following summaries does a better job of summarizing the most important points in a given forum post, and then something blog post, forum post, and then generate a summary and generate a summary B, A-B pair, then GPT-4 decide A or B. Then so this new prompt is added, so some complicated instruction. So because the instruction required a good summary is both precise and concise. So, so the redundant or too long summary should be worth evaluation. For this prompt, okay, so the GPT-4 experiment is as follows. So the first part is red table. The red table is about the possible soundness to regard GPT-4 as a proximal metric of the human scores. So, for example, so GPT-4's prompts and human already for the 70% for the DPO or something like. So this table means so GPT-4 judgments and the actual human evaluation are not so different. Ideally, this table should be 100%. Okay, so the green table is about the comparison between method DPO and PPO or SFT. So the DPO is better than PPO for any prompt. Winner percentage is DPO is 47, 55, and 58. Yeah. So, okay. This means so DPO outperforms with this human evaluation and automatic GPT-4 evaluation scheme. Okay, so the end. Okay, is there a question about experimentation?
No, thanks, but a very interesting paper. Thank you.
Yeah.
Okay. Anything anyone else wants to add or ask? Yeah, thanks again, Atsushi. That was a really thorough presentation. Okay. If not, I think for next week I had put up a proposal for this review paper on a lot of different like research in agents. So if people are interested in that, it's a pretty long kind of review paper, and I think obviously with the review papers you can like read all of the linked papers as well. So if anyone else wants to kind of tackle that with me, let me know. But I think we'll do that next week. Yeah, and if you have any other suggestions or follow-ups to this or anything, also feel free to add it there and we can get to it soon. Is there anything else you'd like to cover related to this, Atsushi, or?
Not yet.
Not yet, okay. Okay, then I suppose we can end early. Yeah, I'll link the I put the link for the paper that I was considering for next week. If you want to give that a pass over and let me know if it's a pretty long one, so not sure I would be able to get through the entire thing myself, but either we can just split it up into 2 weeks or we can address it some other way here. I'll link it in our Google Meet. And then, oops. Yeah, it's kind of very different than what we just read, but kind of relevant to some stuff that I'm working on. So I think it makes sense to cover that.